Welcome to NucleCast, the official podcast of the NY Deterrence Center. Each week, we bring you leading experts for a lively discussion on topics related to strategic nuclear deterrence. Our host is Dr. Adam Lowther, Director of Strategic Programs at the National Strategic Research Institute. The views of the hosts and the guests are their own.
Welcome back to another episode of NucleCast. Of course, I'm your host, Adam Lowther, and today we have with us Angela Sheffield, and she is the Senior Director of Data and Artificial Intelligence at Raft, which is a company that supports the Department of Defense. And today we are talking about AI, ML, and how it could potentially impact NC3. You know, it's for those of you that may remember, I wrote an article a few years ago called America Needs a Dead Hand. And all of you, everyone unanimously said, Adam, you want Terminator, you want, the Whopper, you want all these bad things to happen. So, we haven't had that many episodes to talk about this topic. We've talked about it once or twice in the past, but I knew Angela and I thought, this would be a great topic. She's at the forefront of it, so she's working it and actually working with the DoD to make this happen. So with that said, Angie, welcome to the show.
Thanks for having me.
So, you do this. I sort of know some about it and have a bit of an idea. And I've looked, thought about, well, how do you keep AI from making the kinds of mistakes that everybody fears? But could you maybe start off by giving folks who sort of know they've heard AI, they sort of know kind of what it is, but can you sort of explain what it is, in sort of those layman's terms?
Yeah, for sure. It's funny, conversations about AI always start this way. And it's interesting, they've started this way since this modern wave of AI, which has been, I think, since like 2014 or so. And I don't know, it's a little bit of I take it as a measure of increasing interest in the field, but our definitions haven't gotten any better, even after all those years. Not any easier, I think, to understand. And I think that's because AI is such a huge and diverse field. It's kind of like saying chemistry, which I'll say because I know the audience, but it is really that big and that diverse. But it's also helpful to have like a common starting place and useful definitions to work with. So I'll share a couple that I work with. So AI generally is, or not generally, but kind of specifically, technically, especially from like a scientific discipline perspective, is the study and design of agents. So technology systems, agents that can sense, adapt, and act. So it's very simple, but it's a huge category. Traditionally that has been a computer system, not just like a stupid robot. It's had some of that computer computation aspect to it. I think when we're talking about what an AI is, like a specific AI thing, that is a combination of data, and not like all data, but a specific subset of a specific data type, a modality, a specific, a range of it taken over a certain area or for a certain time or for a certain application, like a very specific bundle of data, plus a model, plus some compute. And there are some fun ways to play around with that mix of things. Most of the AI coming out of commercial is based on AI where you have tons of access to data. And actually, if you can appreciate, that little 3Z, that triad, well, I don't want to abuse the word triad for this audience, but, that set of three, there's some form function relationship between the data and the model or the algorithm, So if you have big data, you use particular types of algorithms in building AI. And those algorithms are machine learning, they're deep learning, but they're not at all the only algorithms. And in fact, in national security, in nuclear security, we don't have access to data in the same way that the commercial sector does. Sometimes we do have very large data sets. I think many of us are familiar with some very large, think of seismic monitoring, CTBTO, like that's a lot of data. But if you're not getting a regime of the system that you're interested in, you can't just go collect more data necessarily. You can't, if you're missing a representation of a type of test activity, you can't just, you can ask somebody to do that test, So we have some different challenges because of that data aspect. When it comes to nuclear, there are some emerging things in the DoD, especially around that compute, because we're waking up to the fact that especially when you're thinking about doing something with the AI in an operational sense, you may not have access to all the compute you want. Think again of like, a seismic monitoring station. You don't have a supercomputer there. So there's a lot of really interesting interplay with that we forget when we're playing with stuff like ChatGPT, because those solutions come from this like boundless, they're the types that you have unlimited data, unlimited compute, and you get ChatGPT. But that's not always the way that it is. But then certainly can't go much farther without talking about, there is like the senior leader definition of AI, which is, it'll do all the things. It'll just make all the things better. And we're working on aspects of that happening. But just like chemistry, it will come in specific solutions, and then maybe, an understanding of the types of techniques and solutions that match to different problems. And, from that, we'll develop repeatable approaches and maybe even, but it's not like all the AI is going to necessarily solve all that problems. It's as hard as anything else is, especially talking to this audience, it's as hard as the work that we normally do. Very hard.
Yeah. So if you think about when and where AI would be useful in the nuclear field, and, I sort of thought, well, the place it would be most useful would be in NC3 to speed up that process of, vetting information.
Mm-hmm.
We have this detect, decide, direct process that we go through that we want to be able to do faster and faster and faster because our time continues to shrink. And then we, like with hypersonics, we might not know exactly where something's gonna hit, and they're harder to track. And so you have attack time compression. So how can you integrate, or when might you integrate AI in that process in a way that, because everybody fears, taking the man out of the loop. So when and how do you foresee that could be potentially beneficial? Or is it never beneficial?
It will be beneficial in some place. It's not ubiquitously beneficial. I'll just say one thing before we dive into the NC3. So a lot of my research over the last 10 years has focused on nuclear nonproliferation. And we did see a very cool opportunity to apply AI to enhance nuclear nonproliferation, treaty verification, counterproliferation, especially in a regime that has been inaccessible to us with traditional approaches. So our audience will know traditional approaches have focused on material signature, chemical signatures of nuclear material, physical signatures of the processes to produce nuclear material, seismic signatures from tests. All of those are very late indicators of the progression of a nuclear weapons development program. But kind of again, form function, much of our ecosystem is built around developing the techniques. That's just what we have a lot of capability in, and the solutions, the tools we go after with are well suited to that, like modeling and computational science. That's all grounded in that same very physics constrained space. But AI is sometimes better suited for data sets or challenges that aren't well described by physics. I won't go into like the math of the AI, but sometimes it helps us get after things where we don't have analytical solutions. We don't even have Monte Carlo type simulation representations of these systems. And AI has helped us go after that. So that's gotten us, you asked about timeliness and faster decision making. That has helped scooch us left of boom in the nonproliferation space. But it's again, this matchup of the algorithm with the sort of data you're going after and the strategically relevant indicator that you're getting from that. And we just found this really happy marriage in the early proliferation detection space. And we can talk about that more if you want to. But in terms of NC3, one exciting thing that we're starting to see as AI actually gets into production and use is especially given that, kind of back to this, resources will be limited sort of problem, which we all have known for a while working on AI for really hard problems. Again, we can't collect all the data we want. Sometimes you won't have the compute you want. Decision makers won't have all the information. Resources are limited all over the place. That's one thing. And then the second thing is that AI solutions are so specific to the thing that you're looking for. So you can train a model. I've done train a model on all the previous examples that you've ever seen. But when we have an NC3 challenge, is that going to be in the data set that we have? Maybe, maybe not. But all of this is pointing to that the use of these technologies in executing something like NC3, in supporting battle management like in JADC2, is going to be very dynamic. And it's going to require a watch office, like an operations center, like we would expect. We'll have an AI solution running on a particular data set, or to, to generate some blip that's on a commander's screen. And then we'll lose that data feed, or we'll drift out of the bounds of responsible use for that AI algorithm. And the commander, in partnership with whoever the AI technologist is, the task force in operations or supporting that NC3 thing, will have to decide, do we change this algorithm in real time? Do we do something that doesn't have to do with the AI? Do we task another resource? Do we plug in another comm system? But it's going to be a very dynamic thing. Sometimes when I talk to senior decision makers, they're like, well, why will there be so many more decisions? And this is one of those reasons. For each of these AI-powered things that we're incorporating into the whole NC3 flow, it's going to require this on-the-loop management of those three things I mentioned: the data, the algorithm performance, and the compute resources that you're putting to it.
So if, the way I sort of envisioned it, and I would describe it more as incorporating machine learning, that you would essentially create, James Reason's Swiss cheese model, where it's not like that there's one algorithm and that one algorithm makes all the decisions,
Mm-hmm.
but that, in all of these discrete processes, because NC3 is, it's a system of many systems.
Mm-hmm.
And that within all those systems, you can have multiple, machine learning tools that are processing information. They can vet each other. They can do all the kinds of things to make sure that the information you're ultimately getting and pushing up to a decision maker, that it's good information. Is that a feasible way to look at it, or am I looking at it wrong?
No, that's the only way to look at it. Yeah, it will be a collection of, and I even have a hypothesis about artificial general intelligence that's along this line, but it will be that a term that we are liking to use as we develop these solutions for the DoD are, it's an open ecosystem of solutions. So there are going to be tons of things in here. DoD will have to figure out how you manage all of that. But again, that gets to some of that human in the loop stuff, like which algorithm do you pull in to but you're correct. Each step, each input, each component may, some of them won't be AI enabled, but for the ones that are, it will be maybe even a collection of things that support that one input. And when I was at DOE and NSA, that was how we had many examples of that was how we were approaching developing, especially much more comprehensive solutions for, say, nuclear test detection. It was very much a component system of systems thing. Sometimes you have, sometimes another place for AI or computational techniques like AI, not machine learning, but graph analytics, for example, which is a not emerging, but increasingly recognized core capability in AI. You have another algorithm like graph forming the interstitial parts between all those different components. Even that might be dynamic and you might change it, but there's a lot going on. Yeah, there'll be a lot going on.
And so one of the big concerns with this is that, as the AI learns, that you can't really vet it.
Mm-hmm.
And that's one of the biggest complaints, for people say, for the nuclear community, where you're very sort of, there's, zero mistakes. How do you deal with that aspect of AI?
when we think about AI hypothetically, it is impossible to vet it. But when you're building, again, in that component-based thing that you're talking about, think of that. Everyone hold like one part of NC3 in your mind. You know what you need. You know what you would need from any solution to support that component. And a domain expert or someone that's been responsible for that capability forever, brings a lot to the table in terms of verification and monitoring and what you need to see from it. And then AI scientists have another understanding when it comes to the algorithm, or statisticians to the data, but when it comes to building confidence and V&Ving a specific AI system, that's a lot more transparent, a lot more doable than just thinking generally about how we're going to trust AI. And I like that approach. So I like this really component, piecemeal, specific approach. I like it as we think about what these solutions are going to look like. But I've also found that approach to be most promising and successful when we're building and integrating AI solutions into NC3 or into the nuclear nonproliferation ecosystem. Like, this isn't a, whatever they say, bite the whole apple thing at once. No, it's take little components in, validate that they do better than something that you had before. It does something a little bit better than the exact thing you were doing before. And then you integrate that, you watch that. There are some emerging technologies and practices that help with that real-time monitoring of AI systems in a far more transparent way. But we can talk about if there's any interest, but just rest assured, from that side there is, but really it comes from pursuing specific AI solutions for that specific component. And that is a doable challenge.
So we're at that time in the show where we have to take a quick break. You're listening to NucleCast, and we'll be right back. This episode of NucleCast is brought to you by the ANWA Deterrence Center, whose mission is to educate Americans about the nuclear enterprise and strategic deterrence. And we're back, and we're talking to Angela Sheffield. We're talking about AI, ML, and how and when and under what conditions it's worth incorporating into, nuclear writ large, but NC3. And so I guess my follow-on question would be, is for folks who want to make sure that the NC3 system is secure, because as we move from kind of an analog system to a digital system, security has become sort of the biggest challenge that we face. How do we make sure the Russians, the Chinese, the North Koreans don't get into the system? I mean, as I think about, if I'm a Russian and I want to attack the United States, what I want to do is I want to it's not that I want, to attack the U.S. I just want to make sure the U.S. is blind and deaf, and so that they can't act. And so as you think about incorporating these kinds of systems, explain security for us, and how does it work, and is it better or worse than our typical digital cyber systems? Help us to understand that better.
I'll answer in a slightly different way first. So one thing that I like to bring into how I see us pursuing AI and how I lead us to develop AI, like for Raft and other places, is these systems, like you can imagine to use the phrase lots of people are familiar with, black boxy solutions or something like that, but that's really not going to be what works when we're incorporating AI into these solutions. Nobody needs to learn that lesson. Like, please just take it from me. These solutions have to be human-centered, designed to be interpretable. When you're making math choices, when you're choosing your algorithm at the beginning, try to choose something. And there are some algorithms that are more human interpretable than others. The national labs have done some really interesting work in more inherently models where it's easier to attribute where the response is coming from in a model. It's not impossible. That is impossible in a deep learning model. But that means we have to choose models where it's easier to provide that transparency to. We have to bake that in, as people say, way from the beginning. And I'm also excited about that because we will shine a light will shine light into those areas, advance that science as we hold to that requirement that our solutions have to be human-centered and transparent because they're supporting these really important processes. So all that said, there are AI is not any more susceptible to cyber threats or digital threats than other technologies. There is even like when we think about stuff like data poisoning, and everyone's probably familiar with the examples of the Post-it notes on the stop sign, spoofing the computer vision algorithms. There you can spoof anything. There's no additional, there's no greater threat with the introduction of AI into these systems than any other digital or detection system. They're still brittle if you use an optimization type approach. If you don't do a great experimental design of that data set, you're going to miss, those same things that we know as scientists and engineers apply. But of course, if you're not making sure that the way that you're approaching that is transparent, has those ways of attributing system response, provide that human in the loop visibility, you may not know. So that is where certainly some of those concerns have come from. And there are so many very public examples of mistakes, like designing very biased AI systems. So we do have to do good work. And again, an AI solution has to outperform an existing national security solution that we've invested blood and country in developing. So it's a very high threshold, and you're taking on the cost of incorporating a new solution. So where we're successful incorporating AI-enabled solutions, it's not going to be easy work to develop them. But generally, they're no more, at risk from cyber or digital threats or information threats than anything else. But because of some of the peculiarities of working with the algorithms, it can be challenging, but everyone's got that in their field. So we have to do our best.
Yeah, I kind of saw it as they're far less susceptible just because, let's take, for example, missile threat detection. And you take, you have space-based assets that, detect IR signatures. And then, those get classified, and then you start projecting flight paths, and, and you have a pretty good data set that you can train that algorithm on. Let's suppose you have an algorithm, and you've got, and it's solid data. And then you're not going to be just introducing a lot of random data that I think would be easy to trick it. So to me, it seems like you would have greater fidelity in these kinds of systems, and they would be harder to spoof or trick than, some of the stuff we've seen where, AI's been trained to be, racist, or, because that has lots of people are introducing lots of training data purposefully, trying to, get it to do the opposite of what it was designed to do. Whereas with missile threat stuff, or, pick some of the other things, the other elements of NC3, those aren't going to be things that people get on the internet to just try to, screw with what you're trying to do. It's pretty hard to create this quote unquote bad training data.
It's an interesting observation. In some ways, in some ways I agree. This a bit goes back to AI being chemistry, as broad as chemistry. One of the things that you talked about, kind of looking overhead at airplanes, that's a particular subfield of AI, and it might be a highly constrained problem. And actually there's a lot of history of outperforming humans in visual recognition tasks, though there are some challenges with actually getting data that's representative of what we expect to see in a DoD, or kind of DOE at an NSA application. So sometimes but that's again where, you'll be substituting it in for anyway. But I wanted to pull the thread on. I love that you, of course, know, and our audience will know, nuclear is a in some ways, fairly constrained thing. NC3 is constrained in that it's our systems and it's DoD, and we're watching for these specific things. And the nuclear fuel cycle is highly constrained by physics and chemistry. But AI models, this field is still mostly driven by the commercial sector. Most of those models don't care about. They're not designed to incorporate any sort of constraint information, or the fact that you only, those constraints don't help us. Sometimes if we're using AI in the way that it is just, kind of off the shelf developed to, in that case, it's strictly data driven. So you can't incorporate any of that physics. You can't. So there's still a lot that we can do, but it's such a relevant observation. But again, when you slice it with the nuanced big field of AI, it's yes, no, in some places, but I'm not at all concerned that we won't figure it out. I think that there'll be tons of great applications of AI and other emerging and traditional technologies as we build out NC3.
Yeah, it seems, for those who worry a lot about AI, it's a human created thing. And so therefore it's going to be as good or bad as its creators. And so if you have an inadequate team of designers and, you don't have the social scientists, but you're going to talk about social science with it, then you're probably going to have some problems. Or, you could think of 1,000 other ways you might have those deficiencies. And I wonder, so I guess we're kind of at that point in the show when Bob comes out. So I don't know if you knew, but I have a genie. His name is Bob. He's, if I pull him out and I rub my little lamp, Bob pops out. He gives my guests 3 wishes every episode. So it's now time where I kid you not, Bob's going to give you 3 wishes. Now, your wishes are constrained to the topics we're talking about on the show today. So if you want to make 3 wishes from Bob about what we're talking about today, what would your 3 wishes be?
One wish would be these wishes are hard because I want them to happen in a very responsible and adequate. But I would love to see and I know this is a little adjacent to your community, but again, speaking for the non-pro side of the nuclear security community, I would really love to see us, and no offense meant at all to our important longstanding capabilities in chemistry and physics, geophysics, none of that. But I would love to see greater recognition of non-traditional approaches towards early proliferation detection, CR research strategies, there are national strategies centered on that, and then sort of the policy and approach and general strategy for nonproliferation realigned around that center focus would be one. Is it cheesy? Or maybe your guests don't normally wish for this, and if we really can wish, can the DoD get everybody better computer? Can we fix some of the, it's such normally when we're talking IT or AI, it's such a cop-out answer to say, but again, this is a different audience. So, honestly, truly on the ground, the long pole in the tent for a lot of the development and integration of these solutions is insufficient infrastructure and tools. And I don't know what would happen if that problem were solved, but it would be awesome if that problem were just solved and we couldn't point to it as why we're insufficient anymore. And then 3, be cool, not to have nuclear war. Is that also a cheesy throwaway? Why not?
Yeah, it's, Bob he's an all powerful genie, so we'll see what he can do. So now you mentioned nonproliferation. How do you, I've sit on the DoD side my whole career, so I wasn't a non-pro guy, but the one thing that, I've been looking at and doing some work on South Korean assurance lately. And one of the things the South Koreans say is, hey, listen, American deterrence of the North has failed. Mm-hmm. You were going to deter them from building nuclear weapons. Not only did you not deter them from that, but they're building an incredibly capable arsenal. So it would appear that non-proliferation has failed. American non-proliferation efforts of North Korea have completely failed. So for South Koreans, how do you, as you think about future non-proliferation, if you have a proliferator who's, hell bent on it, what do you do at that point? And this is sort of the South Korean dilemma as far as whether they go nuclear themselves, because it seems like the North Koreans, it's a poor man's arsenal or a poor man's deterrent to the U.S. is, hey, nukes are much cheaper. They spent $4 billion over more than a decade. And that's how they, for $4 billion, they were able to build a nuclear arsenal and deter the US. That's a pretty cheap price. So from a non-pro perspective, how do you address that challenge?
Adam, we could have had a whole section on this. It's such a rich and interesting topic. In non-pro, I'm not even really, I'm like, kind of a technologist who's gotten to hang out with but I guess I kind of have gone into non-pro myself as it is. But we often, suffer from that proclivity to do that projection, think mirroring, So we often say these they're going to do it the way we would have. They're going to do it the way it's been done before. I have a lot to say on this. I think that AI presents some. So first of all, there's my first wish, which speaks to. We'll let your listeners connect some of those dots there, but it speaks to adding more tools to the toolkit to address this scenario that you've brought up. But I would ask our community, even in non-pro, probability and statistics, so we've mentioned social science, but bringing the mathematics and modeling along with social science, really looking at the evidence that we have collected, not just as like single point, like, AQCon looked like this, so-and-so's breakout looked like that, South, everyone points to South Africa, but really understanding that within a modeling framework of what, not just fuel cycle or not just freeze frame, not this one single pathway, but what is the realm of the possible? Why do these two proliferators look like this? And what do we expect from, we haven't used those tools in non-proliferation before, ever. I think that there is work to do there that requires some humility and like looking at something like South Korea and saying, where did we fail with North Korea? Shining a hard light on where we have invested in, why it hasn't worked. So there's a lot to be done, but we have a lot of ways to go about doing it. And I encourage us to, as a community. It kind of, again, goes to my first wish. But the other thing I would say is that we forget, because we haven't done treaty negotiation for a long time. We haven't, really exercised these tools. We don't have any, active treaties right now. We haven't exercised these tools in a really flexing their muscle sort of way for a while. So we forget the non-proliferation as part of the whole story. It's not that we just expect treaties or, radiochemical particle collections or seismic monitoring to have deterred North Korea. I'm not saying that was a success, but it is part of the whole U.S. strategy to support it. And if it provides some transparency into what's happening, if our non-proliferation techniques, maybe they're providing transparency and not doing deterrence in that way, but it's not too dissimilar, or in that application, it's not too dissimilar from that reckoning that we have to take in deterrence community, which is deter who from doing what, and really have a way to measure if that is working and hold ourselves accountable to that. There's the same thing in non-proliferation. What is this program in non-proliferation deterring or coercing or influencing or monitoring who doing what? And really look if those programs are achieving our overall security aims.
Yeah, well, unfortunately we're at the end of the show, but I think we'll have to have you come back and give you some more time, because I said, hey, let's talk AML. And then, next time I'll say, hey, let's talk non-pro, counter-pro, and you'll have, time to sort of get your thoughts prepared, and we'll talk about that on another episode.
Awesome. Well, I'd be thrilled to come back.
Yeah. Well, thanks for being here today. I mean, it was an interesting discussion, and it was one that we talked about things that I haven't talked with folks about before. So it was enlightening to hear some of your thoughts in terms of how do you foresee how this is going to work out, and, how do you do it, and how do you do it appropriately? And so it was interesting.
If I may share with the listeners, I've seen a lot of AI development, have been a part of a lot of it. And the nuclear security community, again, is at the center of driving important solutions to advance the science, of integrating it into our national security systems, verifying it and validating it. So again, you said you didn't talk about AI a lot. Maybe not a lot of your listeners feel like they are touching it yet. but I do want the community to know that we are leaving our imprint on AI from an S&T perspective, and as we look to integrate it into national and global security.
Awesome. Glad we're not left out.
Not at all.
All right. Well, Angela Sheffield, thanks for joining us on this episode of NucleCast.
Thanks for having me.
And thanks to you, the listeners, and we'll see you on the next episode. Well, lots of information there. I think I followed everything. Hopefully you followed everything. It's one of those, difficult topics where you kind of have to understand it, understand the technology, and sort of think through, how this might work. And so, Angie did a good job of helping us do that. And, I learned something, because there are elements about it that I hadn't thought about before. So I'm glad Angie was on the show to sort of talk me through it. And hopefully you thought it was interesting as well.
This has been a production of the ANWA Deterrence Center. Our executive producer is Kimberly Charrington, and this episode has been engineered and mixed by David Krumthal. Follow the show on LinkedIn, Facebook, and Twitter at NucleCast. Listen, follow, and review the show on Spotify, Apple Podcasts, Amazon Music, or wherever you listen to your favorite podcasts.